Here we are looking at example 3 from our 4.27 notes. We're told that a jump on a pogo stick is modeled by this particular function, where x and y are actually representing kind of distances in terms of inches. Because if you think about a pogo stick, when you go up, let's say you're going up on your pogo stick, you're kind of in the air right now, and then you come down, you land some distance away from where you originally jumped from. All right, even if you jump up and then come back down, even if you think that you are landing exactly where you once were, you're actually not. There's always going to be a very, very tiny, minute deviation from where you left off. So unfortunately, there's always going to be a little bit of a distance, but that creates then your quadratic where you go up and then come back down. Now again, x and y represent these kind of distances. So this x, this change in x right here, because this was 1 point, this was the final one when you landed, that represents some distance there. And then likewise, there's some height that you actually went up for your pogo stick. Sometimes you go a little bit higher, sometimes a little bit shorter, depending on how good your pogoing skills are. Now, when we're trying to find the maximum height achieved by that pogo stick and the horizontal distance, it's basically going to come down to graphing this item. So if, for example, just clear these. There we go. We'll start off by just kind of graphing our XY plane. And we know, though, that our vertex is going to be at 5.5, comma 15. So we'll just say that 5.5. 1, 2, 3, 4, 5. And then there's 6. So 5.5 is about there. And we'll say 15 is reaching that highest point. So there's 15. So there is about that point. That would again be our vertex. Now again, with the vertex, we always get our axis of symmetry. So you can kind of just go up and down, creating that mirror that we've talked about. Now if you think about it, the left side should totally match the right side. So in other words, wherever you jumped up from on the other side, you should pretty much be landing from on the opposite end. So what we're trying to actually find here is at what x value did we actually jump from? Because we don't really know. Maybe it's the origin, could be the origin, but we're not 100% ironclad. So what we're going to do is to try and determine where did we jump from. Actually, I'm sorry. So then for our maximum height, we see that it is at 15 inches. Our max height. It is 15 inches. Now, we're not really sure yet, though, about the horizontal distance traveled. In other words, when he went up in the air and then came down. We're not really ironclad sure about that. But if you assume for a second that he started at the origin and that at that vertex 5.5, he traveled 5.5 inches as he went up into the air, reached his highest point, and then came back down. Well, keep in mind, the axis of symmetry should be kind of like that mirror that we've talked about, so the left side should really match the right side. And as a result, he should be landing on 5.5, again, was this piece? Well, it should be 5.5 on the right as well, giving us that a total of 11 for that horizontal distance that he traveled. So our horizontal distance should come out to be 11 inches.